When you board a plane, you have likely noticed the swirl or white hash in the middle of the engine, turning slowly like those hypnotic videos on YouTube. But behind that little swirl is the most complex piece of engineering. It's one of the jet engines powering your jet. At the dawn of the 20th century, the very idea of powered flights seemed like a distant dream. But we have seen incredible progress in quite a small time frame. At any given moment, there are something like 5,000 flights zipping over the United States alone. We're so used to the idea of flights that we barely even notice all the planes screaming above us, hauling hundreds of people at a time to their homes and holidays. Most modern planes are powered by jet engines, but what exactly are these magic machines, and what makes them different from the engines used in cars or trucks? Welcome back to our channel. Today we're going to take a closer look at jet engines, but before we dive in, make sure you subscribe and hit that bell icon so you never miss a video from us. First, what is a jet engine? Jet engines create forward thrust by taking in a large amount of air and discharging it as a high-speed jet of gas. The thrust from one or more engines pushes the plane forward, forcing air past its wings to create an upward force called lift, which is what powers it into the sky. But that explanation is technically how planes work. How do the engines work? Jet engines comprise of 5 main components: the fan, the compressor, the combustor, the turbine, and the nozzle. One way to understand modern jet engines is to compare them with the piston engines used in early airplanes, which are very similar to what we still use in cars. A piston engine makes its power in strong steel cooking pots called cylinders. Fuel is sent to the cylinders with air from the atmosphere. The piston in each cylinder compresses the mixture, raising its temperature so it either ignites spontaneously in a diesel engine or with help from a sparking plug in the case of a gas engine. The burning fuel and air explode and expand, pushing the piston back out and driving the crankshaft that powers the car's wheels or the older plane's propeller before the cycle repeats itself many times per minute. The amount of power a piston engine makes is directly related to how big the cylinder is and how far the piston moves. Unless you use big cylinders and pistons, you're pretty much limited to producing less amounts of power. So if you try to use that model to power any of our modern Boeings and Airbuses, you're going to have a tough time. It limits how fast you can fly, how much lift the plane can make, and how much it can carry. The modern jet engine makes its power by converting the energy and fuel to kinetic energy to make a plane soar through the air. Let us break it down for you. If a jet is going slower than the speed of sound, the engine moves through the air at about 600 miles per hour. A fan at the front sucks cold air into the engine and forces it through an inlet. This slows the air down by about 60%, and its speed is now 240 miles per hour. A second fan, called a compressor, squeezes the air, thereby increasing its pressure by about 8 times, which dramatically increases its temperature. Liquid fuel is squirted into the engine from a fuel tank in the plane's wings. Meanwhile, in the combustion chamber just behind the compressor, the liquid fuel mixes with the compressed air and burns, giving off hot exhaust gases and causing an incredible spike in temperature. The burning mixture reaches a temperature of around 1650 degrees Fahrenheit. The exhaust gases rush past a series of turbine blades, spinning them like a windmill. Since the turbine gains energy, the gases will lose the same amount of energy, and they will do so by cooling down slightly and losing pressure. The turbine blades are connected to a long axle that runs the length of the engine. The compressor and the fan are also connected to this axle, so as the turbine blades spin, they also turn the compressor and the fan. Hot exhaust gases exit the engine through a tapering exhaust nozzle. Just as water squeezing through a narrow pipe would accelerate dramatically into a fast jet, the tapering design of the exhaust nozzle helps accelerate the gases to a speed of over 1,300 miles per hour. So, the hot air leaving the engine at the back is traveling at over twice the speed of the cold air entering it at the front, and that's what powers the plane. Military jets will often have an afterburner that squirts fuel into the exhaust jet to produce extra thrust. The backward-moving exhaust gases power the plane forward. Because the plane is much bigger and heavier than the exhaust gases it makes, the exhaust gases have to zoom backward much faster than the plane's own speed. Need an easier way to remember it? Pilots often recall the various stages stages of an engine with the phrase suck, squeeze, bang, blow. We're not kidding. The fan sucks in the air is squeezed through a series of small spinning blades attached to a compressor, then fuel is injected into the compressed air and ignited, which would be the bang, and then the rapidly expanding hot gas mixture passes through the turbine. And all jet engines work in this way, meaning all of them share 5 key components: an inlet, a compressor, a combustion chamber, and a turbine with a drive shaft running through them. And the similarities end there. There are many types of engines with extra components like an additional combustion chamber or multiple turbines. Turbojets, for example, have the simplest kind of jet engine. It moves a plane forward by firing a hot jet of exhaust backward. The exhaust leaving the engine is much faster than the cold air entering it, and that's how a turbojet makes its thrust. In a turbojet, all the turbine has to do is power the compressor, so it takes relatively little energy away from the exhaust jet. Turbojets are basic, general-purpose jet engines that produce steady amounts of power all the time, so they're great for small, low-speed jet planes that don't have to do anything really remarkable. But these days, jet engines are far more advanced than that. Now they have huge fans in the front, and instead of shooting the gas out the back directly, it goes through a second turbine which powers the fan in the front. While older jet engines took a smaller amount of air and accelerated it a lot, newer jet engines take in more air and accelerate it a little. This results in the engine using up much less energy. On the other hand, ramjets and scramjets have an engine with the inlet designed as a rapidly tapering nozzle, so the incoming air is compressed without a compressor or turbine to power it. Since they need the air to be traveling fast, they are suited to supersonic and hypersonic planes. Air moves faster than sound as it enters the engine and is compressed and slowed down dramatically to subsonic speeds, mixed with fuel and ignited by a device called a flame holder, producing a rocket-like exhaust similar to that made by a classic turbojet. Ramjets are typically used on rocket and missile engines, but since they breathe air, they cannot be used in space. Scramjets are similar, except that the supersonic air doesn't slow down anything as much as it speeds through the engine. By remaining supersonic, the air exits at a much higher speed, allowing the plane to go considerably faster than one powered by a ramjet. Theoretically, it would be 15 times the speed of sound. 3 things make the modern jet engine more powerful than a piston engine. Number 1. The law of conservation of energy. Simply put, if a jet engine needs to make more power each second, it has to burn more fuel each second. The jet engine has been designed as such so it can draw in huge amounts of air and burn it with vast quantities of fuel, roughly in the ratio of 50 parts air to 1 part fuel. Number 2. Because intake, compression, combustion, and exhaust all happen simultaneously, a jet engine produces maximum power all the time, unlike a single cylinder in the piston engine. And number 3. Unlike a piston engine which uses a single stroke of the piston to extract energy, a typical jet engine passes its exhaust through multiple turbine stages to extract as much energy as possible. This makes it much more efficient since it gets more power from the same mass of fuel. And just in case you were wondering, that little spiral in the middle of the engine is to let people know if the fan is spinning or not. If you enjoyed this video, don't forget to hit the like button and check out more on the Simply Tech channel. Want to know how other things work? Comment down below and we'll make a video on it. Thanks for watching, and we'll see you next time.